Hi, just wanted to do a quick update on this Bluetti AC500 B300S power system, specifically about using it as home backup in the context of a UK electrical installation. But where I'm in the UK, the power is very reliable. We might get a power cut perhaps once a year, and even then that's only going to be like for a few minutes maximum. I can't remember the last time we had any extended power outage. But obviously, if we did, it would be very annoying to have this thing sitting around there and not actually be able to use it if we did get one. But also, there's another application is that my energy provider Octopus has this system to incentivize reduced consumption at peak hours. When they think there's going to be a particularly high peak on the grid, they give you a warning about a day before, and they'll give you a bonus based on how much you reduce your energy consumption over that period of time compared to the average of that period of time over the past few weeks. This sort of does allow us some scope to provide some savings, and I've made about sort of £10 worth of bonuses or something just by switching the whole house over to this during that period. Unfortunately, because the times aren't very predictable, it's difficult to sort of game it by sort of upping your consumption on like the previous week or anything. At least you can actually reduce the power to sort of effectively zero during those periods. Bluetti have sent me the connector. I believe this is actually now available. I'll put a link to it down below. This is made by a company called JNICon. I had a look on their website. I couldn't find this particular connector, so I don't know if this is a custom or a special, but I think even if it's a standard product, it'll probably be quite difficult to buy in single quantities, so I think you're probably stuck with buying it through the Bluetti website, so I think it is actually now available. And this is like a bayonet lock, so it just plugs in and then locks fairly well, so it feels fairly chunky and rugged. Now there's a few ways, sort of different ways of doing this. Basically I wanted to go for the simplest solution, but which was safe and compliant with at least the spirit, if not the actual letter, of the UK wiring regulations. There's a few approaches to this. The problem is obviously you need to arrange it in such a way that it's not possible to have the output connected while your grid connection is still there, primarily because it's just probably going to blow the arse out of the output if this thing sees mains on its output. And obviously you also don't want to be sort of powering the rest of your neighbourhood. In areas like the US, sort of this is talked about quite a lot, where it's not uncommon for a house to be on the end of a single high voltage transformer, so backfeeding into that could put high voltage on the line, which could be hazardous. In the UK that's less of a problem. It's just the fact that you're basically going to be connected to the rest of your neighbourhood, so it's just not going to work. UK electrical systems are fairly standardised, and we typically have a consumer unit. I'll show a picture of a typical one here. And there's not much in the way of standard accessories to allow sort of any sort of changeover type operation. So basically what you really want is something which will literally switch over between the input connection and the grid connection. Now there's a few other permutations. Obviously the Bluetti can act in like a UPS mode, so you can wire it in line of a load. The problem is that your average UK house supply is fused at typically between 60 and 100 amps, and obviously this wouldn't be able to handle the pass through of that current. We'd have typical loads would be say 7 kilowatts for an EV charger. Electric shower could be up to 10 kilowatts. We might have like an induction hob or an electric oven, and that could be 3 to 4 kilowatt sort of loads. So one approach would be to split the load, so you have like two separate distribution boards, one for the high loads and one for the stuff that you want to back up. That involves quite a lot of work, rewiring and so on. For just an occasional thing, I wanted to try and find what's the cheapest reasonable way of doing this. So basically the way I wanted to do this was just have a changeover switch on the feed into the distribution board that could just switch between grid and backup, and obviously just not use any of the high loads during the time the backup supply is running. It's not a safety issue. It just means this thing will just trip out. If I turn the electric shower on, this thing will just trip out from overcurrent. So it's just an inconvenience thing. But I think for this sort of situation, like a manual switch over, I think is perfectly fine, because I might want to use this in other applications. I've just wired a lead to a standard 32 amp 230 volt connector. I mount the corresponding inlet connector that I can then just plug this in as and when I need to. So I had a look around at what's available in terms of just physical switches. Now the only thing I could find sort of from UK supply was this. This is like a sort of two-pole, sort of two-way two-pole isolator switch rated at 125 amps. This is available both as a single unit and also a complete unit in a box. Now, when I was looking, I couldn't actually find the separate unit in stock anywhere, but I'd also had a look around to see what I can find elsewhere, and there's a couple of devices on AliExpress. One was a simple changeover, which is what I eventually used, which I'll show you in a minute. The other one was this. This is basically a dual 63 amp breaker, which is interlocked, so only one side can be on at a time, it trips the other one. When the other one's turned on, you can't hold it. Even if you try holding it, it still trips out. So, I mean, this would be a reasonable solution. Problem with this is, because this is effectively two independent devices, you'd have to bust the two inputs together. Also, it's got this half-width section for the interlocker. Standard fuse would be done in multiples of single units, so for example blanking plates and so on, so you'd end up with like a half-width gap. So I mean, that's a possible solution, but say it's only rated at 63 amps. This is a circuit breaker, not just an isolator, so if you're replacing an incoming sort of 63 amp breaker in a situation, that might be a solution, but it doesn't really work for what I want to do. Typical UK distribution boards, and you have like a 100 amp isolator on the incoming supply, and a very common situation is that then is split into two and feeds two RCDs, residual current breakers, or GFCIs as they call them in the US, and then half your circuits connect to each one via sort of standard overcurrent circuit breakers like this. The other sort of more modern approach is where you just have the incoming main switch and an RCBO. This is a sort of effectively combined circuit breaker and residual current device. If you've got one of the older systems that has two RCDs, one advantage of converting to RCBOs is you actually gain some spare slots. Normally you have two of these, that's taking up 4 slots. Whereas if you just replace all your existing breakers with RCBOs, then that gives you effectively 4 free slots, because all the solutions for doing the switch over use more slots than the standard incoming breaker. So that's a handy way of both improving your installation and gaining some free slots. This is my house setup. Now, one reason I didn't go for that changeover switch in the external box, I just didn't have space. You can see we've got the incoming cutout. This is basically where the power comes into the house. This is very typical of what you see in UK houses. This has got a 100 amp fuse fitted, and then that goes into the meter, and then that goes into the distribution board, often called a consumer unit in the UK. As you can see, I don't really have a great deal of space, so I've put that the 32 amp up there, and there's not really space for anything else. So what I've done is I found this changeover switch. This was on AliExpress. This is a 100 amp changeover switch. I'll just pull the cover off this and show you some more detail. One nice thing about this switch compared to the other two I looked at is this actually has internal wiring for the changeover function. So we've got just 2 connections on one side and 4 connections on the other. Unfortunately, just because of the way this is arranged, I actually had to mount this upside down to get the live out to match up with the bus bar. And this is just a copper bus bar that feeds all the other breakers. This unit also had a copper bus bar that went up from the neutral bar down into the neutral out, but because of the this distance here, that wouldn't fit, so I just replaced that. I had this double heavy-duty tail, which I think may have actually been from the original dual RCD installation, so I just used that to replace the neutral bus bar. So there's 2 wires purely because it was just a thing that I had to hand that was obviously had suitable current carrying capability. So here are the red and black are the incoming tails from the meter, and then these brown and blue are the connections to the 32 amp inlet, and then so this goes out to the rest of it. The other thing I like about this one, it's similar to the that dual breaker in that it does have a centre off position. That UK 125 amp unit I found doesn't have a centre off, so it's literally A or B, and there's no way of having a centre isolated position. So to switch over, this has got a 100 amp rating, but it's not a good idea to switch these things with a load. So generally it's a good idea to just switch everything off, and then that goes to the centre. That's everything off, and then I'll switch that down, and then once the backup unit's plugged into that thing, everything's back and running again. And the nice thing, this is only a sort of a 4 unit wide switch, so just compared to the original switch, this is only another 2 units wide, so it doesn't need a great deal of extra space to fit. I actually already had the space in there. I previously converted this from dual RCD into RCBO, so I already had the space for it, so that was just quite a nice solution. So it's a very simple solution. It's just really the inlet and that changeover switch, and that's all, so it's fairly minimal effort. Now that's fine for the situation where I've got the Bluetti or other backup device in the house near the distribution board. There is another possible future scenario though. There might be a case where I actually want to have the backup source located in the workshop. Now that's located sort of down a 30-metre run of 10mm cable. It's got its own sort of separate distribution board. So for example, if I ever get around to sort of figuring out how to get power out of my car I'd have power at the workshop location, or for example, if I wanted to chuck some solar panels on the roof, charge the Bluetti directly from those solar panels to avoid having to have an inverter. It might make sense to have the Bluetti located in the workshop. Now this thing gets a bit more fiddly. Now obviously I could just run a suitably heavy cable all the way back to the house, but that's quite a long run. It'd be a bit of a pain to run that cable. So I spent a bit of time thinking about that, and I think about the only sensible way to do that would be to have a contactor here at in the workshop end, which is powered from the backup side, but with an interlock connector. I need to have like a low current wire that runs back to this distribution board with a switch which only closes when this is in its center off position, because obviously if it was to close when it was connected to that local backup connector, then the pins on that backup connector would be live, which you don't really want. So what would be nice is if there was a way of getting a version of that center off switch which had an additional auxiliary connection that only closed when it's in that center off position, which I've not seen anything vaguely resembling that. You'd have to sort of cobble something together mechanically, but that then provides that safety interlock that if this was ever removed from the center off position when the backup was active, it would drop the contactor out and disconnect the backup source. Okay, now there is a sort of subtle complication to all this, which the more you think about it, the more sort of complicated it gets. In practice, if you're only using this for sort of occasional use, statistically it's very unlikely to be an issue. But this is basically the situation we've got. We've got incoming grid line and neutral. We've got other houses in the street potentially connected across there, and the normal earthing arrangement in the UK is called TNCS, where the earth that's distributed around the house is actually connected to the neutral at the point where it comes into the house. Now mine's actually not like that, but it's probably the most common situation. Our supply is going through an RCD to our load, so obviously the idea about the RCD is that any leakage to earth from a, say, faulty appliance or water ingress or whatever will cause an imbalance in this current and trip the RCD. That relies on the fact the neutral is at roughly earth potential, either at the house or at the substation. Now, if we go to our backup supply, this is effectively completely floating, which means that any short between either of these sides on earth won't trip this RCD, because that leakage won't produce any significant, because this is floating. What will happen is that the average potential of the floating supply will just bounce up and down. So although it means it won't trip the RCD, in practice, safety-wise, because it's floating, means that there'll be negligible current flow. So in fact, it's probably not a particularly high safety risk. And obviously, if there are multiple shorts, then that changes things. But in terms of the loss of RCD protection, it's not something that's of huge concern. Again, I'm not super familiar with UK wiring regulations. I'm sure it probably has something to say about this situation. I honestly don't know what it is, so if you know details, then please add it down in the comments. That's not what I was referring to when I was saying about the spirit of the wiring regs. I'll get onto that in a minute. But one potential situation you can have is if there's a fault in the street, and obviously if you have a power outage, that could be because there's a fault in the street. And let's say we have a neutral fault. This is generally regarded as a PEN fault, predictive earth neutral fault. What effectively happens is that our live goes through our loads on the other houses, and effectively your earth that's distributed through the house is at mains potential. Now that may sound terrible and horrific, but actually the way that the electrical systems in houses are designed is that everything within that house, for example the water and the gas services, are actually bonded onto this earth. It's called equipotential bonding. So even in a fault situation where your earth that's running around your house is at mains voltage, there isn't really access to a true earth inside the house. So if you touch it, you're going to be at mains voltage, but because everything else, for example if you're in the bath, that bath is bonded to this, so you and the bath and the water will all be at mains voltage, but there won't be anything to actually close that circuit to allow current to pass through. Now this has been an issue with EV charging, where you've got your EV set outside charging plugged into your EV charge point, and obviously the chassis of that is connected to mains earth. In the event of a PEN fault, then effectively the whole car becomes live. Because that's generally set outside, there is a chance that you could touch that and current could flow, and that's why in the UK charge points have to have some means of protecting against that, and there's various ways of doing that, but it basically detects that situation and disconnects the earth as well as the conductors. In terms of just the backup situation, the PEN fault situation I don't think is, because you're still working on the principle, this is the house, this is everything inside it. The only thing potential safety issue is that in the case of a fault, an RCD won't trip, but because the source is floating, the consequences of that are significantly reduced, but also the fact that it's only going to be running on this backup for very short periods means statistically the chances of that being an issue are greatly reduced. So it's not something that's a particular concern, I think. What you could perhaps do is link the neutral of your backup port to earth there to effectively simulate the effect of that neutral to earth bonding on the incoming supply. Then your RCDs would work. I don't think there's any particular sort of downside of doing that. So you would get the RCD protection because this source was no longer floating. So again, please leave in the comments if you've got any opinions, either sort of what the general practice would be, also what the regulations actually say in that situation. The other aspect, which I sort of alluded to earlier, if I'd used the external switchover unit, then I think that would have been completely compliant with all the UK wiring regs. I can't see any respect in which it wouldn't be. Adding that switch inside the consumer unit, now this is a slightly controversial subject, and I think it's sort of getting into the weeds of administration and paperwork rather than actual sort of safety, is that it's argued that inside a consumer unit, you're only allowed to put things which were manufactured by the same manufacturer of that consumer unit inside. I believe the way this is actually expressed in the regulations, in that the regulation says that everything must be installed according to manufacturer's instructions, and some, but definitely not all, manufacturer instructions actually say that you can only put things in the consumer unit which were manufactured and approved by the manufacturer. I have read a few, and I did find at least one that didn't actually say that. I can't remember now what that was and whether that's a current or an old one. But a consumer unit is basically, it's a tin box with some breakers in it. So, and it's a standard DIN rail breaker. Everything's the same mechanical standard. These days, generally the bus bar heights are the same. So although it could be argued that putting, let's say, a different manufacturer's circuit breaker in there isn't strictly compliant with the regulations, I think it would be very hard to make any argument that it's a safety hazard and that it's something which would, for example, fail in inspection. I think at very worst it would be a C3, which is the code for improvement recommended, unless what you put in there was something which is actively hazardous. But as long as the actual electrically it's sound, I think the argument that just because it's something that the manufacturer didn't make, if that thing itself has the appropriate approvals and meets the standards, I think it's quite hard to argue that it's really an issue putting a different manufacturer's, say in this case a changeover switch, into an existing consumer unit. If the manufacturers would actually produce this kit, then I'd be more than happy to fit it, but in my case it actually wasn't possible. I didn't have the room for an external switch, and the manufacturer of my consumer unit doesn't make a changeover switch, so that was really the only option I had. I would be interested to see your comments, but say that's a slightly controversial topic amongst electricians. So back to the Bluetti. The times I've used it, it's worked absolutely fine. It's handled all the loads, including I've got an air conditioner which I use as a heat pump for heating, and that's got some sort of significant switch on surges, and it just handled that no problem at all. The Wi-Fi connectivity is useful because obviously if I'm in the workshop running on this I like to keep an eye on the state of charge. That generally works. It does drop out now and again, and probably the main criticism is that when it drops out, it'll either freeze the display or it will show 0% rather than giving a message explicitly saying connection lost. But it does seem to recover the connection and sort of basically work, so from that point of view I'm sort of quite happy with that.